Okay, so what we're going to do tonight is just more of what we did in class with 5-4 in our trig proofs. I just want to go over two trig proofs with you, one of which involves multiplying by a conjugate, or could involve multiplying by a conjugate. So our first one here, sine x over 1 minus cosine x equals 1 plus cosine x over sine x. So this is one that we're going to work with, and both of these I don't really see a place to start because there's nothing squared, there's nothing to factor, there's nothing to distribute. So I'm just going to pick a side and work with it. It does not matter which side, just pick one that we're going to leave alone, and then we'll work with the other side. So I'm actually going to leave the right side alone, and I'm going to work on the left side. So when I look at what I have, like I was saying, we don't have anything squared, but that's kind of where I want to go. So this is where I'm going to use a conjugate. So remember, conjugates are like a minus b and a plus b. These are conjugates, same numbers and expressions, but with different signs in the middle. So I'm going to take my denominator, figure out its conjugate, which is 1 plus cosine x, and I'm going to multiply that conjugate on both the top and the bottom. And one of the reasons that we like the conjugate is just like over here, when we have a minus b times a plus b, when you FOIL them together, you get a difference of squares, a squared minus b squared. And that's exactly what's going to happen on the denominator when we multiply these two together. So on top, I'm just going to leave it as sine x times 1 plus cosine x. On the bottom, I'm going to FOIL it together. 1 times 1 is 1, negative cosine x plus cosine x minus cosine squared x. These two add up to 0, so we're left with sine x times 1 plus cosine x over 1 minus cosine squared x. So from here, I've done the conjugate and I've simplified. And so now I do have something here, this cosine squared, 1 minus cosine squared x. You can think Pythagorean identity. And so if we rewrite that with the Pythagorean identity, so again, this one, if we take sine squared x plus cosine squared x equals 1, and minus the cosine squared to both sides, we'll get that sine squared x equals 1 minus cosine squared x. So that means I can write in my denominator sine squared x. So when I look at where I am now after that substitution, I can cancel the sine x on top with one of the sine x's on the bottom, and that leaves me with 1 plus cosine x on top and a sine x on the bottom, which matches what I've boxed, so I know I'm done. So this is how we would use a conjugate to help us in our verifying. And even if we had boxed this side and worked with this one, we still could have done the conjugate. It just would have been 1 minus cosine x on top and bottom. So you can use these either way to make something squared or to try to make one of your identities if it's not there to begin with. Okay, our second example that I wanted to do with you is one that doesn't necessarily include a conjugate, but it does include a little bit of factoring. So this next one, 1 minus secant cubed alpha over 1 minus secant alpha equals tangent squared alpha plus secant alpha plus 2. So again, when I look at this to figure out what side am I going to work with and which one am I not touching, I want to see which one I can maybe see a couple things to do. So if I look at the left, up on top, I have a difference of cubes that I could factor. And then from there, I might be able to cancel something. So I can think of a couple things I can do. On the right, if I were to try factoring, I'd get stuck because these aren't the same trig function. So the only thing I could think of would be maybe a Pythagorean identity to go in here. But still, I'm not really sure what would happen after I plug that in. So I'm going to go with, again, boxing the right and working with the left. So if I factor the top here, 1 minus secant alpha, and then our pattern is, if we remember, we square the first, so 1 squared, same, opposite, and then we'll have our always positive at the end here. So now we would want to multiply these two together, secant alpha, and then square the last, secant squared alpha. And then all of this is over 1 minus secant alpha. So right here, I notice I can cancel the 1 minus secant alphas. And 1 squared is 1. I have my plus secant alpha. And then I have my secant squared alpha. So I'm looking close to what I want, but I need to somehow get a tangent in here. And so how can I get a tangent into my problem with where I am now? So I notice I have the secant squared. I'm going to think, what's the Pythagorean identity that goes with it? So if we think back to what is our Pythagorean identity. Sorry. Our Pythagorean identity says that secant squared alpha equals 1 plus tangent squared alpha. So if I substitute 1 minus tangent squared in for secant squared, I get 1 plus secant alpha plus 1 plus tangent squared alpha. So I have my tangent squared, I have my secant, and if I add the two ones together, I'll get my 2. So I can write this as tangent squared alpha plus secant alpha plus 2, making it look exactly like what we were trying to prove, so that we know we're done. So when we get into class tomorrow, we're just going to be doing more of these trig proofs and practicing with some of the different methods like conjugates or some different factoring to try to get used to some of those ideas.